Hi everyone, my name is Gemma Rose Ardinglas, saying don't assume too much. Before you assume, learn the fact. Before you judge, understand why. Because sometimes what is expected is different from what is observed. And this is somewhat related to my topic for today, the chi-square test of goodness of fit. What is chi-square test of goodness of fit? This is a test of difference between the observed frequencies and the expected frequencies. The goodness of fit determines how well experimental data fits the population or expectation. It is employed when dealing with counts or frequencies for a categorical variable with two or more categories, or what is called a multinomial experiment. Upang mas madaling maunawaan, ang chi-square test of goodness of fit ay ginagamit upang malaman kung ang iyong sample collected data ay may kinalaman o kapareho ba ito ng inaasahan mong resulta or data. How do we use the chi-square test of goodness of fit? Use the formula x squared is equal to the summation of the quantity O minus E squared divided by E, where x squared is the chi-square test, O is the observed frequencies, and E is the expected frequencies. So let's take an example. A certain machine is supposed to mix peanuts, hazelnuts, cashews, and pecans in the ratio of 4:3:2:1. A can containing 500 of these mixed nuts was found to have 270 peanuts, 110 hazelnuts, 80 cashews, and 40 pecans. So these are your observed variables. At 0.05 level of significance, test the hypothesis that the machine is mixing the nuts at the ratio of 4:3:2:1. Solving now by stepwise method. First is to identify the problem. Is the machine mixing the nuts at the ratio of 4:3:2:1? Then, formulate the hypothesis. First is the null hypothesis. The machine mixing the nuts at the ratio of 4:3:2:1. Next is the alternative hypothesis. The machine is not mixing the nuts at the ratio of 4:3:2:1. Then, we have the level of significance. Alpha is equal to 0.05. The degree of freedom is equal to h minus 1, where h is the number of samples. So for the example, we have 4 types of nuts. That's why we have 4 minus 1, which is 3. And for our tabular value, we have chi-square at 0.05. So now we will be using the chi-square table. So this is the chi-square table. We need to locate the level of significance at 0.05 and the degree of freedom, which is 3, then get their intersection. Therefore, the tabular value is equal to 7.815. Next will be the statistics. As we can see, we have here a table of data from the example. From the first column, we have nuts. The second column, we have the ratio. The third column, we have the observed. And we have the fourth column, which is empty for the expected. For expected, we have to divide the total observation by the total ratio. So all in all, we have 500 nuts, then divided by the total ratio, which is 10. 4 for peanuts, 3 for hazelnuts, 2 for cashew, and 1 for pecan. a total ratio of 10. So 500 divided by 10 is equal to 50. Now let's get the expected for peanuts. 50 times 4. Since 4 is the ratio of peanuts, so we have 200. 50 times 4 is equal to 200. Then for hazelnut, 50 times 3 is equal to 150. For cashew, we have 50 times 2 is equal to 100. Then pecan, we have 50 times 1 is equal to 50. Now we already have the following data. So let us solve it by using the chi-square test formula. So x squared is equal to the summation of O minus E squared divided by E. So let's solve this. X squared is equal to, let's start with the peanuts. The observed frequencies for peanuts is 270. So 270 minus 200, which is the expected frequency of peanuts, is squared divided by 200. Plus, second is for the hazelnut. The observed frequencies of hazelnut is 110 minus the expected frequencies, which is 150, is squared divided by 150, plus the cashew, 80 for observed frequencies minus 100 for the expected frequencies, is squared divided by 100, plus the pecans, 40 for the observed frequency minus 50, which is the expected, is squared divided by 50. So x squared is equal to 24.5 plus 10.667 plus 4 plus 2. So x squared is equal to 41.167. So let's take the decision rule. If the chi-square computed value is greater than the chi-square tabular value, this confirms null hypothesis. Now we have the conclusion. The chi-square computed value of 41.167 is greater than the chi-square tabular value of 7.815 at 0.05 level of significance with 3 degrees of freedom. So the research hypothesis is confirmed, which means that the machine is not mixing the nuts in the ratio of 4:3:2:1. It implies that the machine is not in good order because it does not mix the nuts as expected. And that's how we solve the chi-square test of goodness of it. Thank you for listening and God bless you all.